solve and see each of the following equations. The first equation is z squared equal minus 2i. To solve it, I have to replace minus 2i by 1 minus I squared, and we get z equal 1 minus I, or z equal minus 1 plus I. Second equation is z cubed equal 1, which leads to z cubed minus 1 equals 0, and we factorize it using the identity a cubed minus b cubed to get this equation, and we solve it using calculator. This part we can use the calculator. Third equation is z power 4 equal 1, and so on. Here z squared plus 1 means z squared minus I squared to get this, and we get these four answers. Nth roots of a complex number, the definition is if z is a complex number and is a positive integer, we call nth root of z any complex number u such that u power n is equal to z. So u is the nth root of z. Application 1 plus 2i squared is equal to minus 3 plus 4i. Then we say 1 plus 2i is a square root of minus 3 plus 4i. And the other square root is minus 1 minus 2i, of course. This complex number j equal minus half plus I radical 3 over 2 satisfies the equation j cube equal 1 shown here. When we solve the equation z cube equal 1, we get z equal minus half plus I radical 3 over 2. Also like this, 2 plus I cube is equal to 2 plus 11i. This means that 2 plus I is a cubic root of 2 plus 11i. The two other cubic roots are u times j and u times j squared. Nth roots of unity, we mean by unity 1. 1 and minus 1 are square roots of 1, because 1 square and minus 1 square gives 1. 1j and j bar are the cubic roots of 1, as shown in the activity. J is minus half plus I radical 3 over 2. 1 minus 1i minus I are the fourth roots of 1. Means when we make them to the power 4, we get 1. Forms of the nth roots. If z is a non-zero complex number, algebraic form z equal x plus iy, u equal a plus ib. U is the nth root, means u power n equals z. We get this equality. We replace it by exponential form. When we compare it, we get the power here with the power, and theta equals alpha plus 2k pi, and rho power n is equal to r, which leads rho equal radical r of index n, and theta alpha over n plus 2k pi over n. We replace them in the exponential form of u. We draw radical r of index n, we put it here, and theta we put it here to get this exponential form. So here, when we replace it, we have to replace k by the values 0, 1, and minus 1 to get the roots m0, m1, m2, and so on. The points here are all on the same circle. O m0 or m1. The radius of this circle is radical r of index n. And the images are the vertices of a regular polygon. Means all sides are equal. Calculate the fourth root of a complex number z equal minus 4. We write minus 4 in exponential form. We get 4ei pi. And we write the exponential form of z. By comparison, we get rho power 4 equals 4, and 4 theta is equal to pi plus 2k pi. And we get this. Final answer is z equal radical 2 ei pi over 4 plus 2k pi over 4. Of course, to get the four fourth roots, I have to replace k by 0, 1, 2, and 3 to get these answers. Their images are respectively the vertices of a square. This is the figure. To draw them, For example, M0 is the image of Z0. Its exponential form is radical 2 ei pi over 4 means OM0 is radical 2 and the argument is pi over 4. Properties as written in the book. Let us find the cubic roots of Z equal I. First way, algebraic way, it is known as algebraic way, x plus iy. We replace Z by x plus iy. Sorry, assume u equal x plus iy, u cube equals Z. We expand and we get this. By comparison, real part equal to real, imaginary equal to imaginary. We get these two equations and we solve them to get x and y. Second way is known as exponential way. We write I in exponential form, which is ei pi over 2. The cubic roots are radical 1 of index 3, I pi over 6 plus 2k pi over 3. When we replace k by 0, 1, and 2, we get the 3 cubic roots. Third way, I, we can replace I by minus I cube, and it means that u cube equal minus I cube, which means minus I is the first cubic root, u equals minus I. The two other cubic roots are u times j and u times j bar. Homework exercise 3 parts 1 and 3. Thank you.